In this video, I will go through the section 2.4 of chapter 2 of FS1, which is mean and variance of a Poisson distribution. We say if x follows a Poisson distribution with the rate of lambda, mean of x is the same as expected value of x, which is equal to lambda. Okay. Variance of x is equal to, we represent with variance of x equal to sigma squared equal to lambda. So, in Poisson distribution, variance and mean are equal. Okay, it's not always the case in other sort of distributions, but in Poisson distribution, this is the case. So therefore, two important factors which we need to remember: mean of x for Poisson distribution is lambda, and variance of x, which is sigma squared, which is the same as lambda again. Therefore, variance and mean are the same. So let's look at to this example, example 7. A botanist counts the number of daisies x, okay, in each of 80 randomly selected squares within a field. Okay, the results are summarized as below. Sum of x, so E of x, is equal to 295. E of x squared is equal to 1386. So the x's are not given separately as the previous example which we did in previous video. Okay, instead E of sum of x is given here. Okay, so all the x has been added, and which is 295, and so on for x squared. Part A. Calculate the mean and the variance of the number of daisies per square for the 80 squares. Give your answer to 2 decimal places, and we explain how the answers from part A supports the choice of a Poisson distribution as a model. Okay, and part C, using a suitable value for lambda, estimate the probability that exactly 3 daisies will be found in a randomly selected square. Okay, let's go through the solution now. Okay, so right, solution for example 7. It says sum of x is equal to 295, and sum of x squared is equal to 1386. So we want to work out mean and variance. So to work out mean, x bar is equal to sum of x divided by n. It already says what is n. N is in each of 80 randomly selected squares. So n is 80. I write down n equals to 80. So therefore 295 over 80, which is equal to 3.69 to 2 decimal places. Okay, so what is variance? Variance is equal to sum of x squared, or from previous lesson we know we can apply the formula sum of x over n minus sum of x over n all squared. Okay, so it's up to you which formula to apply, but since we don't have the formula for the we don't have the x values, therefore we have to apply this one, sum of x squared over n minus sum of x over n all squared. Okay, so sum of x squared, which is 1386 all over 80 minus sum of x, which is 295 all over 80, so square that, and as a result we get 3.73. So variance is equal to 3.73, and we got x bar is equal to 3.69. So we clearly see that x bar, which is mean, is very close to the variance, almost equal. Okay, so when it is equal, then the Poisson distribution could be a good model for the given data. Explain. So this is the answer. This one is the answer for part A. Okay, for part B, it says explain how the answers from part A supports your choice of Poisson distribution as a model. Both the mean and variance are 3.7. So both the mean and variance. Round this one rounds up and this one rounds down to 3.7. Okay, correct to one decimal place. The fact that the mean is close to the variance the mean is close to the variance. Okay, it supports the choice of Poisson distribution as a model. So therefore, the most important factor in Poisson distribution is lambda is very close to variance, or mean is very close to variance, and both are equivalent to lambda, which is not the case in binomial or normal distribution. Okay, part C. Using the suitable value for lambda, estimate the probability that exactly 3 daisies will be found in a randomly selected square. So using lambda equal to 3.7, okay, so we have to define our variable x. Let x be equals to the number of daisies per square. Okay, the number of daisies per square. Okay, so therefore x follows the Poisson distribution with rate of 3.7, lambdas of 3.7, and we are looking for exactly 3. Okay, probability of x equal to 3. Okay, so using the calculator for Poisson PD. Okay, we should get lambda is x is equal to 3 and lambda is equal to 3.7, which is 0.2087. Okay, so end of the example 7. Okay, and you should be able to do exercise 2E, which is page 31. And in next video, I will go through the section 2.5, which is mean and variance of the binomial distribution.